going to be talking about segments today. Line segment. Friday we talked about points, lines, and planes, which are undefined terms. We use undefined terms to help us define definable terms. I know that's kind of a wordy sentence, but when we started talking about points, lines, and planes, lines is a straight line that extends forever and ever in two directions, right? It has one dimension. It has an infinite length. But we're going to take that down and we're going to take line and shorten it to something that's definable, and that is a line segment. And I'm going to try to fix some mistakes as we get in here, if this will let me, because a line is not a word, but a line is two words. There we go. A segment, a line segment, is a part of a line consisting of two endpoints and all points in between them. So basically what we're saying about a line segment is that it has a beginning and an end and it's straight. Okay? In this case, this line segment is line segment AB. So as we scroll down here a little bit, the diagram above depicts a line segment with endpoints A and B. A segment is named by its two endpoints. So just as much as understanding what a segment is understanding how to label it, how to see it, see what it's asking for. And so you can see that how it's called or how we label it down below is either segment AB or segment BA, but above it you're going to see a line with no arrows on either end. Okay? Does that make sense so far? This all should be really, really easy stuff, at least for like the first 5 to 10 lessons. Okay? From there, if we can get to the next page. Anytime now. You just do you, computer. There we go. So then we come into some more terms. It says two geometric objects that have the same size and shape are congruent. Here we're looking at basically the simplest thing we can look at, which is a line segment. Congruent segments have the same length. They're both going to be straight, so there is no difference in shape. Okay? So all we really have to do to say that two line segments are congruent is just to determine that they have the same length. So granted, I made these, I didn't necessarily copy and paste, so AB may not visually look like it's the same length as CD in this case, but because I'm telling you they're both 5, we're going to assume that they're the same. Because they have the same length, AB and CD are congruent. Congruent means they're the same size and shape. I believe if you end up looking in your classroom, you're going to see lesson 1 and 2 Quizlet. I've already made flashcards for all your definitions for lessons 1 and 2. At some point, we'll kind of play this out in class and see what you remember. In this figure, AB and CD are congruent. As shown in the diagram, they both have a length of 5 units. Okay? A congruency statement. Congruency statement shows that two segments, and in all reality, a congruency statement is just showing that two things have the same size and same shape. But the symbol, let's see, we need to add something to this. Let's do that right here. It's not just equal to, but it has this little guy above it. Looks like a wave. Okay? It's an equal sign with a little wave above it. Now, a little wave above it, as it exists by itself in geometry, means that two things are similar. When we put it in with an equal sign, we're saying that they are equal and similar to each other. That's how we get what we call a congruency symbol. So that symbol for congruence is an equal sign with a little wave above it, is read as is congruent to. The congruent statement for the segments above is segment AB is congruent to segment CD. That's how we would read it or say it. So in a diagram, congruent segments are shown with what we call tick marks. Okay? What you see there is segment QP is congruent to segment RP, and we show that through tick marks. Okay? The diagram below shows that. So we can not only see it with an equation where we're saying AB is congruent, but we also see it visually on a diagram represented this way. That's going to become really important later on when we start to look at things like how can I prove different aspects of geometric figures. Well, we want to look for tick marks. We want to look for visual indication that certain things are equal to each other. And that's going to allow us to infer or imply more and more details until eventually we get to a final statement of what we're looking for. So you're just now being introduced to this. If you don't get it now, it's going to get really hard later, okay? So make sure that we don't just see this and look at the slide notes, but we're actually picking up on it. If you don't understand it, ask questions. All right. So the following properties apply to all congruent segments. We have the reflexive property, okay? Reflexive property, meaning that a segment can be equal to itself. Okay, and we'll look at instances later on where a segment is equal to itself because you have overlapping parts. Let's see if I can end up drawing this out somewhere else. I'll show you what that looks like. For instance, okay, let's say I've got a triangle here, and how do I want to do this? Okay, something like this. Technically speaking, I have like 3 triangles there, right? I've got this one, and then I've got the whole thing. Let's call this A, B, C, D. Okay, well, both of these triangles share segment AB. Okay, so AB is congruent to AB, even though it's a part of 2 different triangles, because AB is AB. Okay? I don't know. We'll see instances later, but just not real soon. Symmetric property of congruence is if AB is congruent to CD, then CD is congruent to AB. Okay? If one thing is congruent to something else, then something else is congruent to the first thing. Okay? All you're doing is switching the order around. Okay? If they're congruent to each other, it doesn't matter which side of the equal sign or the congruent sign that they exist on. All right? I use something like my hands are symmetrical. Okay? Meaning my right hand is technically equal in size to my left hand. Or I can say that my left hand is equal to my right hand. One doesn't have priority in terms of first place over the second place. Okay? Then we have transitive property. Okay? Transitive property of congruence states that if AB is equal to CD and EF, CD is equal to EF, then AB is equal to EF. Okay? If I have, say, 3 lines, a blue line, a red line, and a green line, and I say that, you know, listen, the blue line and the red line are equal to each other. They're congruent. They're the same length. And I know that the red line and the green line are equal to each other. Okay? They're both the same length. Then what I end up finding out is that the blue line and the green line are equal to each other. Okay, that is the transitive property. Does that make sense? We can follow that? Okay, so those are some ones that you're going to want to know. A ruler can be used to measure the lengths of segments, obviously. The points on a ruler correspond with the points on a line segment. This concept is presented with what is called the ruler postulate. What's more important than the ruler postulate is knowing what a postulate is. Okay, because what we have in math, specifically in geometry, is we have 2 things. One is a theorem and one is a postulate. And we're going to use both of those extensively. And a postulate is a statement that is accepted as true without proof. A theorem is typically proven, and we go through steps to prove theorems. A postulate is accepted as true. We don't have to go through steps to prove that it's true. It's widely accepted and agreed upon. Okay, so you'll see those 2 things show up over and over and over again in your book. You'll see theorem 17-1 and postulate 14-2 or whatever it is. The postulate is already accepted as true. Okay, we don't have to prove that. It would be like, a postulate would be almost like gravity. Okay, it's a fact. Okay. let's see, postulate number 1 in terms of looking at the ruler postulate. The points on a line can be paired in a 1-to-1 correspondence with the real number such that any two given points can have coordinates 0, 1, which means I can take any segment and put it on a coordinate plane and give one endpoint 0, 0, okay, or 1, that type of thing. The distance between 2 points is the absolute value of the difference of their coordinates. This is what they mean by absolute value. If I put something in absolute value signs, how does it always come out? It always comes out positive. So if I put -5 in between two absolute value signs, we're saying it equals 5. And the reason that's important is because if we're using a ruler, what are we measuring? If I pull out a ruler, let's see, I've got one right here. Right? I pull out a ruler here and I measure something. What am I measuring? The length, and another word for length is distance, right? Okay? Distance is always what? Is it ever negative? No, it's never negative. But can I put 2 points on a coordinate plane and one of those points have a negative coordinate? Yeah. Okay? But is the distance between those 2 points ever going to be negative? No. So that's why we say it's the absolute value. Okay? Meaning that if I I'm going to just draw over the top of myself here, and I got a segment and I put it over here. Even though this coordinate section has a negative x value but a positive y value, okay, or if I put something down, put a line down here, that's negative down here. That's negative x, negative y. All right, but the distance is always going to be positive because distance is always positive. I don't care what you do, you can't, walking backwards doesn't mean that you're going a negative distance. You can't put your car in reverse and take the miles off of it, right? Don't you wish you could? Okay, so distance is never negative. Therefore, whenever we go and we use the ruler postulate and we put things on a coordinate plane, no matter where those points wind up on the coordinate plane, the distance between those points is always a positive distance. So in order to figure that thing up mathematically, we have to use absolute values. Here's a picture of that. Okay, now granted, here we're putting A in a positive spot and B in a positive spot. Distance is the measure of the segment connecting 2 points. The distance between 2 points can be represented by those 2 points with no segment symbol. For example, AB means the distance between A and B. If I scroll down here and I wanted to find the distance mathematically, we would say that it's the absolute value of point A minus point B. Now, the opposite is also true because I can go from B to A. I could say point B minus point A. Okay? In this case, if I do A minus B, then I'm saying the absolute value of 4 minus 9. Well, the absolute value of 4 minus 9 is -5, but because its absolute value comes out as positive 5. If I did it the other way around, though, and I went from B minus A, I would be doing 9 minus 4, right? What's 9 minus 4? 5. What's the absolute value of 5? 5. So I'd get the same answer either way. It doesn't matter where I start from. That's like saying, what's the distance between Milan and Kirksville? Right. How many? 32 miles. All right. So you drive 32 miles from Milan to Kirksville. All right. Is it going to be a different distance if you go from Kirksville to Milan? So does it matter where we start from? Should I get the same answer? Yes. And I think that's an important thing to realize, that just because it's this way in your book doesn't mean that if I do it a different way, I'm going to get a different answer. I want you to understand the concept behind distance. Okay, so the distance from point A to point B in this case is 5, and it would be even if we move this over and we had A at -4, we flipped it and we put A at -4 and B at -9, right? What would we wind up with there? If we did that, we would have we'd have absolute value of -9 minus -4, right? All right, well, 2 minuses there are going to be plus. What's -9 plus 4? -5. What's the absolute value of -5? 5. If we did it the other way around and we had the absolute value of -4 minus the absolute value of -4 minus -9, that would still be plus. What's -4 plus 9? 5. All right, and the absolute value of 5 is 5. All right, you see how even though I flipped it over into the negative side of my number line, I still get the same distance. Okay, so I do that, and I show you that, want you to see that, is because your book isn't always going to give you as many different types of examples as I really kind of feel like it should at times. Okay, the segment addition postulate. If B is between A and C, then the distance from A to B plus the distance from B to C is going to add up to the distance between A and C. For instance, if we didn't know how far it was from Milan to Kirksville, but we knew how far it was from Milan to Green City, and we knew how far it was from Green City to Kirksville, we could figure out how many miles it was from Milan to Kirksville, right? Because we could take the segments that we know, add them together, and get the total distance. Okay? Likewise, if we didn't know how far it was from Green City to Kirksville, right? Let's say we don't know how far this is. Okay, but we do know how far this is, and we know how far this is. Right? So let's call this, for instance, let's call this Z. And we want to solve for Z. We want to know the distance between Green City and Kirksville. Well, we know that, X plus Z equals Y. And if I want to know what Z is, I'm going to get Z equals Y minus X. I would take the distance from here to Kirksville and subtract the distance from Milan to Green City. And that's going to tell me how many miles it is from Green City to Kirksville. Does that illustration work for you? You grab that, you understand that, something that you might actually use in life? Where would I actually see this taking place at? Okay. Midpoint. Midpoint basically tells me that I have a point that perfectly divides the distance between 2 points. So the midpoint of a segment is the point that divides the segment into 2 congruent parts. So it has to be equal on either side. And if M is the midpoint of AB, then AM, the distance from A to M, is the same as the distance from M to B. Is there a halfway point between here and Kirksville? Like an exact half? I mean, if it's 32 miles, then we would say, what, 16 miles? Is there something that's 16 miles from Milan between here and Kirksville? Is it Greencastle? Maybe. Let's say Greencastle is the midpoint, right? That means from Milan to Greencastle is 16 miles, and from Greencastle to Kirksville is 16 miles. Okay, we've reached a halfway point. All right. Likewise, let's say I knew that Greencastle was the midpoint, and I know that we're 16 miles from there, but I don't know how far it is from here to Kirksville. I should be able to take, I know that this is 16 miles, and I have my tick marks here. Can I find the distance between A and B? Sure, just double, right? Double the distance from here to Greencastle, right? That's going to give me 32 miles. Okay, I want to use something that you can kind of get your head wrapped around, because when we start talking about different numbers, right, it's going to get a little bit more abstract, and you may have a struggle with it a little bit more. That's it for that. Let's take a look at some questions, if I can pull some of these things up. We may not do all of these, but I want to do enough of them that I feel like you got your head wrapped around it. Let's see, we're out of here at 9. Something like that. 9 o'clock. Okay, we got a little bit later start than I would have preferred. Okay, so let's blow this up a little bit here so we can see it. Okay, point B lies on AC. Okay, between A and C, AB is 3x minus 8. BC is 5x plus 3. Find AC. So we don't know we don't know that B is a midpoint, correct? All right, we don't know that, but we do have the segment addition postulate here, meaning that AB plus BC is going to equal AC. So at this point, I'm doing 3x minus 8 plus 5x plus 3 is going to equal AC. And if you don't see that, then you need to draw it, okay? Here's A, here's B, here's C. AB is 3x minus 8. Okay, this is 5x plus 3. I want to know what that whole thing is, all right? So they're going to give you statements. It's going to help you if you actually draw some pictures. At this point, what do I do with this side of the equation? Combine like terms. What's some like terms in here? 5x and 3x, which is 8x. Okay, what other like terms do I have? Negative 8 and 3. What's negative 8 and 3? Negative 5. So 8x minus 5 comes down as my answer. We got that? Okay. Let's see if I can. Gosh. All right. Here, in number 2, you're looking at tick marks. Okay, so segments that we know are equal to each other because they have the same tick marks. I'm going to kind of fast forward through this. In L, it's equal to what? What is in L congruent to? LP. In P is congruent to what? RS. In R is congruent to PS. So I'd look for the statements down here that match with that. All right, number 3. Identify the property that justifies the statement. Segment AB is congruent to CD, so CD is congruent to AB. What is that? What property? Reflexive, because I'm just flipping it, right? Kind of like a reflex. Actually, no. Is that right? No, it's not right. I would have. Sorry, I almost agreed with you. Symmetric. Symmetric means that I can flip them. Now, if that had said AB is equal to AB, right? Reflexive means to itself. Okay. I'm trying to think of a good way to remember reflexive. When you think about reflexes typically happen at a joint, right? Talking like when somebody tests your reflexes, they're testing a joint. So think of like your elbow, right? We're not looking at 2 separate elbows. We're looking at one elbow, one point. Okay, so we're looking at just a singular point, all right, or a single segment. Does that help at all? I don't know. All right, we've got number 4 here. G is between. This again is. It's a little bit more complicated than just what it looks like, because you have to look in these questions, what is it actually asking for? It's asking for FH. But we do have the segment addition postulate. So we've got 4x plus 14 plus 31 equals 6x. It's not asking for x, but we're going to have to solve for x to get there. Okay? So I would combine these like terms. 14 and 31 is what, 45? Subtract 4x to the other side, right? So 45 equals what? 2x. Divide 45 by 2. What do I get? 22.5, right? And the problem is that a lot of people are going to circle that right there because they found 22.5. But the question is what is this? Okay, so what do I need to do? Plug in x. X is 22.5. 22.5 times 6 comes down to what? 130. Is that 135? It is an option. 135. All right. So just because you see a number that takes place in the work doesn't mean that answer. It doesn't mean that it answers it. So be careful with that. Do we feel like we have kind of an understanding here? I know we just did 4 questions, but with 5 minutes left, I want to give you guys a chance to work. The rest of these questions do show up in the answer key below. You guys have this document. It'd be worth your time to work out some of those problems. And if I'm going to give you a hint, it's because some of those questions that we didn't work out might very well show up on your first test. Okay? So it's worth your time to work through and practice. This, what you see up here, is not your homework. Okay, I've had the new students that I have gotten kind of confused with thinking that this document is their homework. It's not. It's practice to see if you understand how to do your homework when that's assigned. Okay, your homework comes from your ebook or your textbook. All right, so we're going to hit stop right there.